Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on October 22nd, 2025, about 5 days ago. The big result is a simple protocol that hides any secret text inside a different, coherent fake text of the same token length, and it runs in seconds on a laptop. For example, Llama 38 billion does about 5.0 seconds encode and 4.6 seconds decode, while Gemma 327 billion takes about 58 and 59 seconds. The paper is titled, LLMs Can Hide Text in Other Text of the Same Length, and as we will see later, the implications for security and trust are significant. Beyond the core trick, the authors show the stego texts look human plausible, explain that security relies on a secret prompt key and exact model behavior, note weaknesses on niche domains, and outline risks like covertly wrapping unsafe systems inside safe outputs. Alright, the introduction set up the threat and the laptop speed claims. Figure 1 presents a concrete example that makes the idea vivid, with 3 same-length texts where only the middle passage is the original message. The top block reads like a cheerful recipe, yet it encodes the central critique because token choices follow ranks from the secret message. The bottom block praises Caesar, which shows that the hidden content's topic and tone are fully steerable by a secret key. While Figure 1 illustrated the rank-guided trick with same-length texts. Figure 2 shows the core intuition behind steganography. A magic potion barrel concealed among ordinary wine, which conveys hiding a message inside an innocent cover. The emphasis is concealment of presence, unlike cryptography that only scrambles content. The method keeps that intuition, but goes further, since the fake text is generated to look natural while silently carrying the secret. Okay, the previous figure emphasized concealment as a concept. Figure 3 shows the step-by-step recipe that makes it work, which maps the secret text into a list of token ranks, and then generates a same-length cover by picking those ranks under a secret prompt key. The figure illustrates E for the hidden message, K for the style key, and S for the produced cover. Decoding simply recomputes the ranks from S under K and reconstructs E. Low ranks keep the cover fluent and on topic. So, the previous figure laid out the recipe. Figure 4 compares plausibility distributions, showing cumulative log probabilities for 85 token texts scored by Llama 38 billion. The beige Reddit histogram defines the real range, while dark gray random strings sit far to the left, which signals nonsense. The colored bars for 3 sets of fake texts stay inside the real distribution, yet their dashed arrows sit slightly below the corresponding real originals. The takeaway is that covers remain human plausible, though typically less probable than the source messages. Alright, the previous figure showed that fake covers stayed plausible, but slightly less likely. Figure 5 explains why. The left panel reports token rank frequencies, where rank 1 occurs only about 40%, so a rank 1 slot is relatively scarce. The 3 right histograms compare probabilities for ranks 1, 2, and 3, and the real text consistently has higher probabilities than the fake. Many rank 1 chances get spent on middling choices, which lowers overall likelihood. So Figure 5 traced why probabilities drop. Figure 7 contrasts domains under the same secret key on Llama 38 billion, showing how the source message shapes cover quality. The top panels show chess yielding coherent, on-topic prose, and the cover grows longer because chess tokens are dense. The middle panels repeat that success for Python code. The bottom row shows a Romanesco dialect source producing garbled sentences, which signals lost soundness when the model lacks coverage. Alright, the previous figure traced domain effects on soundness. Figure 13 shows cross-model scoring with Phi 33.8 billion, and the pattern holds. Fake covers sit within the real text range, yet score lower than their originals. The dashed markers indicate the real texts, which land to the right of their corresponding fake histograms. So a probability-based judge could still pick the original, while both remain plausible to humans. So, 2 takeaways stand out. The protocol reliably hides one message inside another of the same length by matching token ranks, and the resulting covers remain human plausible while decoding in seconds on commodity hardware. The broader implication is stark. Text no longer signals intent, which enables covert, unsafe systems and complicates content moderation and trust. That is it for the AI Research Roundup. I am Alex. Thanks for listening.